Okay, good day students. We're going to start to look at the total surface area of prisms today. So our learning goal for today is to solve practical problems requiring the calculations of perimeters, and the surface areas of standard 3D dimensional objects. In this case, we're going to be looking at prisms and cylinders. We're going to look at the surface area of a cylindrical food container. So there's no real formula for a total surface area except for adding up all the sides. So we want to convert that into a net. So the total surface area is the sum of the areas outside the surfaces of a three-dimensional object. Now don't get this confused with volume, because volume is what's on the inside or the amount of space that it takes up. So formulas for all types of objects are not possible, but for those without a formula, you just need to follow the following steps. 1, draw the net, which is just the, like unpeeling it if you're going to make it out of paper, I suppose. Work out the different shapes that make up the net, calculate the individual areas, add up all those individual parts. So for example, it's going to be quite easier with a cube because a cube has 6 faces. And those faces are all squares. So if you know one side, all you need to do is say side squared for the area of one square and then multiply it by 6 because you have 6 squares on the outside. Now rectangular prism, well, we've got 6 faces on the outside, but they're going to be a little bit different because we're going to have 3 different sorts of rectangles. The one at the top and the bottom, the one on the front and the back, and the one on the left and the right. So all you need to do is calculate the area of those 3 different ones and then multiply it by 2. Now a cylinder is quite interesting. We've got 2 circles and then we've got this length here, which is the same as the circumference of a circle. So when you're looking at the circumference of a circle, remember it's pi d for a circumference, or 2 pi r, and we'll do that example because that's important. Let's consider this example here. We've got a trapezoidal prism, and it's going to be a bit hard to work out what to create a formula for this, so we'll break it down. So we need to draw the net of the object. We need to work out the different shapes that make up the net. We'll have to calculate the individual areas and then add them all together. So if I want to convert this trapezoidal prism into a net, remember I've just got all the shapes. I've got the front and the back trapezoid, so let's call that the front, let's call that the back. That could be the bottom, and that could be the top, and that could be the left, and that could be the right faces of all of this prism. Now, if I want to have a look here, we've got a base. We've got also a side A here, and this base is also side B in the trapezoidal prism. We've got a slant height of 5, which is important for over here, and we've also got a perpendicular height to work out how high this is for the trapezoid. So there's a lot of different dimensions we need to take. We also note that it's got a width of 2, so the width is here. So if we want to break this down, we can say the surface area is, first of all, 2 times 1/2 of a plus b over h. So that's your 2 trapeziums. And now we want to think about the width and the slant height. So this is our width and slant height, and here's another width and slant height over here. So we've got 2 of those. And then what do we need? We need a width and a base for the side B for that rectangle, and then we've got the top, which is over here. So we've added all those, we substitute the numbers in and then we add them up, and that should get you to 140 square meters. Check your units, make sure you're not telling me that they're meters or cubic meters, because we are looking at the outside area of this. So if I was thinking about this, this could be important for painting or origami, how much paper do I need, or if I'm going to create some food containers. So for example, if we want to look at how much metal is in a tin can, so I went and had a look at the pantry last night and I found this tin can of Aldi beetroot. It's 425 grams, but it's got a 10 centimeter diameter and it's 6.7 meters high. So let's draw this as a net. So that's the shapes. We've got two circles, top and bottom, and we've got this big rectangle. Let's add in our dimensions, 6.7 high. The diameter is 10 centimeters. Now remember the circumference here is also the width of that triangle. So let's calculate the area of one circle. That we could call it the top one. It's just pi r squared. So it's pi times 5 squared because 5 is half of 10. And then that should give us 78.54 centimeters. Circle 2 is going to be exactly the same. No need to repeat the calculation. Now the rectangle, remember, is the length times the width, and the length will be the circumference, and the width will be the height of the can. So pi d, or 2 pi r, for the circumference formula times the h for the height. So it's pi times 10 centimeters times 6.7. That's 210.49 cubic centimeters. So we add them up, get the total surface area. The total surface area is 367.57 cubic